Hello students, welcome to Evershine Coaching Center. Myself Faisal sir here. Dear students, one thing I just want to know before I could start this session, very importantly. This is a chapter which I am going to discuss now, that is acid, bases and salts. In my previous video, I have given the summary of this chapter. In second video, I have completed the important questions with respect to this chapter. And this is my third video which I am going to start now. But certain terms and conditions are there. The students now who is going to face the exam just by keeping 10 or 15 days in your hand, I know you are starting your revisions, so please don't study this video, because in this video the topics what I am showing here, in this I am going to cover your entire chapter, complete full deep chapter information is there, which is not at all required for you at this moment. The students who have the capability or who is very interested, keen interested, sir, I want to score out of 8 marks, then definitely you can go ahead. You have got a ticket, you can move, no need to wait. The students who in average condition or below average condition, so please no need to study. You can study, you can just move ahead. Whichever the topic, content you are not aware, open your textbook, which paragraph you are not understanding, that particular paragraph you can open. If you are finding some answer is very big or difficult, that particular answer you can see through this video. You can just increase the speed of the video. Okay, so just stop the particular part which you want the explanation. You can see to that, because it's my duty to suggest you the right path. Now, I want to tell one more important thing here. The students, after completing your 9th standard, you are going for class 10th. Maybe those belongs to state or CBSE. Any of the student, please watch this video completely. Okay. Now, this is the only chapter which I am going to deal here so deep, because I don't have that much sufficient time to do that. But summary I am going to do, important questions I am going to cover in this YouTube channel, because I am the person who deals directly. I don't want to make others to wait and do my job. No. What I say, I want to do, and inshallah I am going to do that. Right? So please, the students who are starting your career in 10th standard now, who is going to start 10th standard, you people must and should have to go with the entire chapter in detail. While you are studying this, keep your textbook next to you. Okay, next to you, keep your textbook, watch the video, see your textbook paragraph. Both simultaneously you should watch, you should see, and you should make a note. So this is what a perfect revision. Usually I used to do this type of revisions or this type of covering the syllabus in my offline mode classes. Okay, now we are planning to start with online classes also for the academic year plan. Okay, full year plan, full year course. Here also we are going to cover as like same thing how we cover in the offline. But here this is the only chapter I am going to cover so deep and in detail. Okay, let's begin the topic. I hope you understand it. First, I am going to start with indicators. So, indicators are those substances, as I have said you before also. Again, I am repeating the same thing. Indicators are those substances which is used to detect whether the given solution or the substance is acidic in medium or basic in medium. By seeing the color change, or certain criteria will be given by observing changes. But one word is change. By seeing the change, we are going to identify what is that, whether it is acid or it is base. So, these indicators will help us to identify. Now we have different types of indicators, natural indicators. Now these are the indicators which are available naturally. Okay, they are available naturally, like example litmus, turmeric, red cabbage, china rose, etc. So these all are the natural indicators. Now I want to tell something about litmus because that is present in your textbook, that word, and we need to study. If that word has been given in the textbook, that means that we have to cover something related information about that. We cannot stick only that word is there, okay fine, in my textbook it is not present any other extra information. No, you must have to collect some information related to that. Example like litmus, it is obtained from lichens. So the solution of the litmus is purple in color. Usually the solution will be in purple in color. So litmus paper comes in two color, that is one blue and another one is red. Maybe in your school, whenever they conduct some activities, definitely they will conduct this experiment. By taking the litmus paper, they will ask you to identify whether the given solution is acidic or basic in your activity. Okay, if red is converts into blue, then it is basic. If converts into red color, then it is acid. Red means acid, blue means base. Simple. Now turmeric, we can see here turmeric is another natural indicator. So turmeric, usually you have seen, we call that as haldi in our home. Okay. Anyways, turmeric is yellow in color. So turmeric solution or paper turns reddish brown with base. Whenever turmeric, if it is contact with base, it converts into reddish brown color. So turmeric does not change color with acid. Remember, maybe this is examination point of question. Examination point of view. Got it? Turmeric deals with base, not with acid. That is one thing. And color changes. Wherever you find some changes in color, if they have mentioned, please make a note of that. That is very important. Some gases are coming. What is the color of the gas it is mentioned? Make a note of it. That is very important. Don't forget. The property, the nature of that substance is very important. Done? Fine. Now, we are going to study red cabbage. The juice of red cabbage is originally purple in color. Juice of red cabbage turns reddish with acid and turns greenish with base. It means red cabbage, it reacts with both acid and base, and it changes its color. By changing its color, we can identify. Okay. Next, one more type of indicator we have, that is olfactory indicator. So olfactory, where it is in our nose. Simple. Factory, all. Anyhow, by detecting the smell, we can identify whether it is acid or base. Such type of indicator is known as olfactory indicator. Example, onion, vanilla, your sweet sweet dishes, certain things you can see. That is nothing but your olfactory indicators, not sweet dishes, like something we are going to add to get some colors or to get some taste. That is what the things which is being used as olfactory indicators. Onion, vanilla, you can just go ahead. Next is synthetic indicators. So these are the indicators which is artificially prepared in the laboratory. We are going to prepare artificially. Is this clear? Such type of indicators are called as synthetic indicators. Example, phenolphthalein, methyl orange, etc. Phenolphthalein is a colorless liquid. It remains colorless with acid but turns into pink with base. If it is detecting with acid, it doesn't change its color, but when it detects with base, when it reacts with base, then it changes its color to pink. Methyl orange is originally orange in color. It turns into red with acid and turns into yellow with base. Done? Next, we have got certain things in this table. Indicators, original color, acid and base. When they react with acid, what change? When they react with base, what changes? Red litmus, original color is red, no change. With acid, blue. Blue litmus, blue, red, no change. Turmeric, yellow, no change, reddish brown. Red cabbage, purple, reddish, greenish, yellow. Phenolphthalein, it's colorless. Definitely acid also it is colorless, but with base it is pink. Methyl orange, orange, red, yellow. Onion, no change. Small vanishes we can observe. Vanilla also no change, small vanishes we can observe. Done? Fine. Now acids. Some properties of acids we can see here. So acids, they are usually sour in taste. Khatta, we say in Hindi khatta. Okay, it turns blue to red and they dissolve with water to give hydronium ions or hydrogen H plus ions. They release H plus ions. Example, sulfuric acid, acetic acid, nitric acid. These are the different types of acids, and even hydrochloric acid. Okay. Properties of acids. Acids have sour in taste, turns blue redness to red. Acid solution conducts electricity and release H plus ions in aqueous solution. We have different types of acids. Okay. So acids are divided into two types based on their occurrence. How they are going to obtain based on that. We have two types of acids. One is natural acids, other one is mineral acids. Natural acids are nothing but which occur naturally. Okay. Which are obtained naturally. Those are natural acids or organic acids. So naturally means from where we are getting. Kahan se mil rahi humna? That's nothing but organic acid. Means they are going to obtain for us. We are going to get that from plants and animals. That is called as natural acids. We are getting that from plants and animals. Example, methanoic acid, acetic acid, oxalic acid. That's what called as natural acids. Done. Next is, we can see one small table. Here it describes complete information. Acids. Acetic acid, from where we are going to obtain it? From vinegar. Absorbic acid, guar amla, citric acid, lactic acid, methanoic acid, oxalic acid, tartaric acid. My dear students, one thing remember, from this table you can expect one question for your 1 mark. Very, very, very important table. Should not miss this. Because I have observed this ant sting or nettle sting, this has been got in exam. This question we have it has appeared in exam. That is nothing but which is the acid is present in ant sting. They will ask you the question like this. Even tartaric acid is also important. Citric acid, acetic acid, almost every acids are important. So please remember from where we are going to obtain that, from where we are going to get that. You should remember. Again I am repeating, this table is very, very, very important. Should not miss that table, right? Okay. Next, coming back to mineral acids. So these acids are going to get from the minerals of the earth crust. From the earth crust we are going to get this type of acids. Those are called as mineral acids. They are also called as inorganic acids. Your natural acids are known as organic acids. Mineral acids are known as inorganic acids. Different. It means man-made, man-made acids or synthetic acids. They are also called as mineral acids. Example, hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, phosphoric acid. Now we are going to discuss chemical properties of acids. Children, we have totally 4 properties, but I will consider that as 3 properties. Which are the 3 properties? Number 1, reaction of acids with metal. Which is the acid? Reaction of acids with metal. Second, reaction of acids with metal carbonates. Which are those? Metal carbonates. Next is metal hydrogen carbonates. What happens? And reaction of acids with metallic oxides. So these are the different types. One is metal, and next is metal carbonates and metal hydrogen carbonates and metallic oxides. We are going to discuss. Now, which are the chemical reactions I have given here? So please try to learn how to balance it, how to pronounce it, and how to remember the molecular formulas. Those are very, very important. You can expect one question out of this chemical properties of acids. Very, very, very important. Now, reaction of acids with metal. Usually, whenever the acid react with metal, one thing you must have to remember. Based on that, many questions you can expect. Many questions. Remember, many ways the questions will be asked. One thing you should remember in your mind, oh, acid, it is reacting with metal. Maybe it is copper, maybe it is brass, anything. Forget it. Metal. When acid reacts with metal, it gives hydrogen gas. This gas is important. Product is not so much important. But which gas it is liberating, that gas is important. Which is the gas? Hydrogen gas. H plus hydrogen gas. This hydrogen gas, sir, whether it is good or bad? No, it is not good. It is bad. It produces toxic content. So that the taste of the food, the taste of the chemical, the taste of the nature of that particular product will change. It changes entire properties of that substance. So remember, Whenever the acid react with acids give hydrogen gas along with respective salt. Salt is going to happen. We are going to get everywhere we get salt. But the important concept here is which gas is coming. You take one metal, put acid on that, definitely we can see one kind of sound, some gases are coming. The example, आप देखे रहेंगे बेटा. Let you take your dosa, okay, tawa, dosa tawa, okay. On that you just put water. What happens? You can find a jizzing sound over there, right? Similar to that. It's not that, similar to that. Okay, anyways. So when acid give hydrogen gas along with the respective salt when they react with metal. So metal plus acid, this is the important reaction, you should remember. Metal plus acid gives salt plus hydrogen gas. Example, zinc plus hydrochloric acid gives zinc chloride plus hydrogen. You should remember this. Okay, they may ask you the question like this. What happens? Now, whichever the question you see here, please remember, you make a list in your textbook. In your notebook. What happens? This should be the common word for every question. What happens when zinc reacts with hydrochloric acid or HCl? That's it. That should be a question. Try to find the answer and remember the steps as well as learn how to balance it. Okay? And you should write the comment like this. What happens when zinc reacts with HCl or hydrochloric acid? You should write what happens. Yes, we should write like this. How? When zinc reacts with hydrochloric acid, it produces or it forms zinc chloride and hydrogen gas is liberated. This much information you should write, and you should write the reaction and you should balance it. Then you can expect around 2 marks for that if you are going to write this much. Minimum 1 is must and should, but max to max 2 marks we are going to get. Okay. Now in this acids, somewhere again I am going to repeat this word because these words are very important. Dilute acids and concentrated acids. What do you mean by dilute acid and what do you mean by concentrated acid? Dilute means patla. In Hindi we say patla. Concentrated means gada. In milk, if you pour more water, more quantity of water, what happens? The milk content will become less. The water content in that will become more. If we have got more amount of water in that, that is called as dilute solution. If we have got more amount of acid in that, then it is called as concentrated solution. Less water. It should have less water. Less water, more acid. That is known as concentrated. Dilute means more water, less acid. More water, less acid is called as dilute. I hope the concept is clear to you. What is the difference between dilute and concentrated? Right? Done. Now, same way, hydrogen gas and sulfate are formed. What happens when sodium and sulfuric acid reacts? We get sodium sulfate and hydrogen. Now, one experiment is there in your textbook. This experiment is very, very important. They have given in your textbook one diagram. That diagram named as POC test. We are going to identify which gas is coming out. We are detecting that. Which gas is coming? That is hydrogen gas test. We are testing which gas is that. That is nothing but hydrogen gas. This is called as test of hydrogen gas. We are detecting this is hydrogen gas or not. Second, this test is also known as POC test. In this, in your textbook it is mentioned, but we have given some information related to that. The gas evolved after reaction of acid and metal can be tested bringing a light candle near to it. If the gas burns with a pop sound, it comes on the evolution of hydrogen gas. Okay, you can see that experiment and you just read these sentences simultaneously, you will understand. Okay, anyways, I told you next reaction is next chemical property is reaction of acid with metal carbonate. Acid give carbon dioxide and respective salts along with water, and they what happens when acid react with metal carbonates? Acid give carbon dioxide gas. Please remember, because carbon particles are there means carbon dioxide is there. Simple. Salt anyhow we remember. Addition to that, water is there. This one you should remember. Because definitely when carbon dioxide gas is there, simultaneously water is also present. You should remember like this. Metal carbonate, any metal carbonate plus acid gives salt, carbon dioxide and water. Example, this chemical reaction is very important. Should not miss this question. It is 100% guaranteed question. They may ask you this. Maybe you choose the correct answer or direct or indirect in any way. But question is sure. Done? Here, what is the question? What happens when sodium carbonate react with hydrochloric acid? Sodium carbonate, Na2CO3, react with hydrochloric acid. What it forms? Sodium chloride, carbon dioxide and water. Should not miss this chemical reaction. It's very important, children. First only I am saying. Similarly, come back to the next reaction. Sulfuric acid gives calcium sulfate. Carbon dioxide gas, calcium sulfate and water when it react with calcium carbonate. Okay. You can see here what happens here when calcium carbonate or sulfuric acid react with calcium carbonate. What it gives? Calcium sulfate, carbon dioxide and water. We are trying with different examples, but everyone are carbonate. I can see here nitric acid react with sodium carbonate. Here calcium carbonate. Okay. Same way here also. Now reaction of acid with hydrogen carbonates, that is metal hydrogen carbonates, that is also called as bicarbonates. When acids give carbon dioxide gas, respective salt and water, then they react with metal hydrogen carbonate. When acid, first they will do the previous process, like acid give hydrogen gas, salt and water has come. Again what they do? Again they will react with metal hydrogen. After the stage 1, they will react with stage 2. We can consider this as stage 2. Then later what they happen? The product which is obtained, that product again they react with metal hydrogen carbonate. Acid plus metal hydrogen carbonate gives salt, carbon dioxide and water. We can see in both those places it is happening the same reaction. But what is the difference? The difference is we can see in terms of their moles. Once if we balance the reaction, we will understand what exactly is happening over there. Sulfuric acid gives sodium sulfate, carbon dioxide gas and water when it reacts with sodium bicarbonate. Okay. Next reaction is known as test for evolution of carbon dioxide gas. How we have done hydrogen gas, right? Here is a test where we are going to detect it is carbon dioxide gas. Okay, you can just go through it. This also belongs to a metal hydrogen carbonate concept. And here we can see one word is called as precipitate. What is the meaning of precipitate? Can you see this word precipitate here? Yes, precipitate is nothing but once that is formed, again it doesn't react with any other substance. That is called as precipitate. So carbon dioxide turns lime water milky when passed through it. Carbon dioxide turns lime water milky when it passed through it. This characteristic test for carbon dioxide gas. The gas evolved because of the reaction of the acid with metal carbonate or metal hydrogen carbonate turns lime water milky. This shows that the gas is carbon dioxide gas. This happens because of the formation of white precipitate of calcium carbonate. When excess of carbon dioxide pass through lime water, this is very important. Should not forget this word. When excess amount of carbon dioxide is passed, normal gas we are passing, so it is white precipitate is formed, right? Just we are passing the gas of carbon dioxide, white precipitate is formed, okay, of calcium carbonate. But now what happens when excess amount of carbon dioxide is passed through lime water? What happens? It makes milky color of lime water disappear. Important. The milky color what is obtained, right? That milky color will disappear. This happens because of the calcium formation of calcium hydrogen carbonate. This happens because of calcium hydrogen carbonate. Here this is happening because of, this is Milky Way we are getting, this is because of calcium carbonate. Milky Way is disappearing because of calcium hydrogen carbonate. So this is the difference between metal carbonates and metal hydrogen carbonate. Okay, as calcium hydrogen carbonate is soluble in water. This is soluble in water, but this calcium carbonate is insoluble in water. They are insoluble in water, but this is soluble in water. Any doubts? Fine. Similarly, acids. We are going to decide acids in two ways: a strong acid and weak acid. Again, bases also strong bases and weak bases. You can study this. Okay. So these are different types of acids. An acid is completely ionized in water and produces H plus ions. Whenever the acid reacting with water, it gives two types of ions, positive and negative ion. That is H plus ions are going to obtain. Then it is known as strong acid. Example: HCl, sulfuric acid, nitric acid. Out of this, which is a strong acid, very high strong acid, that is HCl. Weak acid, they are partially ionized. They are, once if we are going to dissolve it, ions formation will happen, but partially, not 100%. So the called as weak acids. The best example is acetic acid, is a very weakest acid. Carbonic acid. So these are the different types of weak acids. Done. When concentrated solution of acid is diluting by mixing water. This question has appeared in board exam. This question has been asked in the exam. This point. When concentrated solution of acid is diluting by mixing water, it means they will ask you the question like this. Example. Here we have acid. Here we have water. Here we have water. Here we have acid. So which is the best one, they will ask you. Either you add acid with water or water with acid. This reaction is correct. We should not add water with acid. First let water content be here. You add acid into that. What happens? This reaction is exothermic. This reaction is exothermic. Okay. But here what happens? When you add water into the acid, what happens? The heat will appear. The heat will appear like this. Means more amount of heat will generate in that. Due to which it may splash, it may cause damage to your hand or face, so and so. Understood? This reaction is very spontaneous. But here this is exothermic reaction, due to which what happens? It is safer compared to this. So always we have to prefer, we should add acid with water, not water with acid. Done? So that is what the question here. When concentrated solution of acid is diluting by mixing water, then the concentration of hydrogen ions or hydronium ions per unit volume decreases. Here one more thing what he has said here, according to this statement, you understood, right? Always we should add acid with water. Water is present here, you add acid into that. We are adding acid inside the water. This is the correct one. Okay. If you do the opposite one, due to the more amount of heat generated, it may cause fire. It may cause damage to your face or hand. Now we can see this is the water. Here also we have water. Example. Here I have taken less amount of water. Here I have taken more amount of water. Less water, I am adding more acid. More water, less acid. So what happens? Water content is more, acid content is less. So what happens? The concentration will decreases. Less water, more acid, concentration will increases. This is what it means to say. If the solution is concentrated, understood, the concentration of the acidic medium will be more. If concentration, if it is dilute, in dilute always remember, in dilute acid the concentration will be less. In concentrated acids the concentration will be more. Means which concentration? Concentration of hydrogen ions. H plus ions will be more. Concentration of H plus ions will be more. Is this clear? Now bases, they are bitter in taste, soapy to touch, and they will convert red to blue color, and they perform hydroxide ions. Now remember, one more question you can expect in your exam, bases. No, bases, one word is there, one more word is there here, that is called as alkali. Now, so what is the difference between base and alkali? They both react to the same family? Yes, these both react to the same family of bases only. Bases also belongs to base only, alkali also belongs to base only. But what is the major difference between base and alkali? Alkali are those type of bases, they dissolve in water. Usually all acids, maximum all acids will dissolve in water, but all bases will not dissolve in water. Got it? Some bases will dissolve in water, some bases will not dissolve in water. The bases which dissolve in water, those are called as alkalis. Understood? The bases after reacting with acid, some bases are there, after reacting with acid they produce hydroxide ions. So those are called as bases if they produce hydroxide, but alkali will not produce hydroxide ions. Alkali bases will not produce hydroxide ions and they are alkaline in nature. That also should be. Is this clear? Example, sodium hydroxide, that is called as caustic soda. Calcium hydroxide, that is calcium hydroxide. Potassium hydroxide, that is nothing but caustic potash. Done. Properties of bases, bitter in taste, as I said you, soapy to touch, turn red litmus to blue, conduct electricity in a solution. And one more thing here, conduct electricity in solution. Bases anyhow they are going to conduct electricity in solution. And one more thing I have just forgotten to tell you that dilute acids, remember this, dilute acids will produce electricity. Remember, not concentrated acids. Dilute acids will produce electricity, as well as bases also will conduct electricity. Okay, so they release hydroxide ions in aqueous solution. We have different types of bases. One is water soluble, one is water insoluble, as just before I have said you. The hydroxide of alkali and alkaline earth metals are soluble in water. They are known as alkali. The bases are the metals which are soluble in water. Those are called as alkali metals. Example: sodium hydroxide, magnesium hydroxide, calcium hydroxide, etc. So alkali is considered as strong base. We consider alkali metals as strong bases. Done. Okay. Next is chemical properties of bases. Till now we have discussed chemical properties of acids. Now we are completing chemical properties of bases. And one more I have just left out over there in acids. When chemical reaction of acids with metallic oxides, and the bases non-metallic oxides. That is one is there. Okay. So chemical properties of bases, reaction of base with metal. What happens? Again, this also will produce salt and hydrogen gas. Alkali plus metal, that's nothing but base. Alkali is nothing but base. Alkali plus metal will give salt and hydrogen. Okay, but remember, sir, hydroxide is not there. Why? Because it is alkali. It also belongs to base family only, but it is not 100% base. As I said you, alkali metals will not produce OH minus ions. Understood? Anyways, when alkali react with metal, bases will never react with metal. If base react with metal, it will give hydroxide ions, right? So alkali when react with metal, alkalis will react with metal, not bases. Remember this, very important. When alkali react with metal, it gives salt and hydrogen. Example: sodium hydroxide gives hydrogen gas, and sodium zincate react with zinc metal. So you can just go through these chemical reactions. It's important. Okay. Reaction of base with oxides of non-metals. That is, we know that non-metallic oxide is acidic in nature. Example: carbon dioxide is a non-metal oxide. When carbon dioxide is dissolved in water, it produces carbonic acid. Therefore, when a base reacts with non-metal oxide, both neutralize each other, respective salt and water. Base plus non-metal oxide will give salt and water. Remember this, and remember these chemical reactions. It's important. Sodium hydroxide, this chemical reaction is very, very, very important. Sodium hydroxide plus carbon dioxide gives sodium carbonate plus water. Same way, calcium hydroxide gives calcium carbonate and water when it reacts with carbon dioxide. Is this clear? Fine. Next, neutralization reaction. What is the meaning of neutralization reaction? Means if it is acid or it is base, it neutralizes. It means when acid neutralizes base, when they react with each other, respective salt and water are formed. If it is more acidic in nature, if any substance is more acidic in nature, to remove that acidity, what we should do? We should add base. Same amount of base we should add. So what happens? The reaction will become neutral. If base is more, then we should add acid. Example: you can see farmers. Okay. If sometimes in farmers the fertility of the soil will decrease. Why? Because of more acidity. Acidic substance will be more in the soil. If acidic substances are more, then yielding will not take place in a better manner. So what they will do? They will use quicklime, slate lime. Okay, chalk. This type of substances they are going to use. Means they are adding base, so that the reaction should become neutral. It's very important chemical definition. You should not forget this. They may ask you this question. You should not forget this. What is that question? What is neutralization reaction? What is neutralization reaction? It's important definition. You should remember. And here we have discussed two different examples of hydrochloric acid and hydrochloric acid with sodium hydroxide, and same hydrochloric acid with calcium hydroxide. What happens? Okay. Same way, reaction of acid with metal oxides, acidum, which is left out in acids. Similarly, even here also we can see acid plus metal oxide will give salt and water. Same way. Common in all bases. A base dissociates hydroxide ion in water. Usually bases dissociate with to produce hydroxide ions. Acid dissociates to give hydrogen ions. So which is responsible for basic behavior of a compound? Bases. Okay. When sodium hydroxide is dissolved in water, it dissociates hydroxide ion and sodium ion. Similarly, potassium hydroxide gives K plus and OH minus ions. Neutralization reaction with respect to base. Before we have discussed with respect to acid. Dilution. And I told you one concept over there that acid should be mixed with water or water should be mixed with acid. That concept is being completed here. Okay. And what is the difference between concentrated and dilute is been explained over here in this paragraph. Dilution of acid and base. How to dilute acid and how to dilute base. Okay. This concept is very, very, very important for your exam because one question already has appeared based on this topic. That's the reason. Strength of acid and bases. We can see here. This is the margins. This is 0 and this is 7 and this is 14. Can you see here? It is 0 and it is 7 and it is 14. The region which is coming less than 7, those are called as acidic in nature. The region who is going more than 7, those are called as basic in nature. How it is coming towards acidic, 7 when it is coming towards 0, the concentration of hydrogen is increasing. Can you see this? Here concentration is less, here little more, here little more, here little more. But in this case, opposite what happens? If concentration of H plus ions increases, simultaneously concentration of OH minus ions will decrease in the opposite side. If acidic nature increases, basic nature will decrease. If basic nature increases, acidic nature will decrease. If the pH is equals to 7, that is called as neutral solution. If pH is less than 7, acidic solution. If pH is greater than 7, then it is called as basic solution. Universal indicator. We have one more type of indicator as what we have discussed: natural indicator, olfactory indicator, synthetic indicator, and one more type of indicator, that is universal indicator. So this universal indicator, it's nothing but it's chemical. We get a strip, dip into that. Many different minute color changes will be there. One strip will be there, one graph. You just match with the different orientations. Whichever it matches, it represent. Like 1, 2, 3, 4, what we had here, no? It will tell you exact what is the pH value of that solution. Exact solution we will get. Okay, based on this coding. That is nothing but we call as universal indicator. Okay, by using litmus, just we can tell it is acidic or basic. Your olfactory indicator, natural indicator, synthetic indicator, it just represents whether it is acidic or basic. But how much acidic, what is the concentration of acidity in the acidity is present in that? What is the concentration of OH minus ions are present in that? It doesn't detect. But by using universal indicator, somewhat we can detect even the concentration of that solution also, the pH of that. So pH in our everyday life. So pH in our digestive system, tooth decay caused acid, soil of pH and plant growth. It's very, very, very important question, children. They may ask you the question. Briefly explain the importance of pH in everyday life. It's very important question. So dilute HCl, that is hydrochloric acid, helps in digestion of food. This HCl which is present inside our stomach, which helps in digestion of food, that is nothing but proteins in our stomach. Excess acid in stomach causes acidity. If HCl is increased, if the quantity of HCl is more, then acidity will cause, so that indigestion will happen. Indigestion will happen. To prevent this, we use a medicine called as antacid. Remember this word. We use a chemical called as antacid to remove acidity. It's here only. And antacids like magnesium hydroxide, also known as milk of magnesia, and sodium hydroxide, hydrogen carbonate, that is nothing but baking soda, are used to neutralize excess acid. So these are the different ways or methods to prevent excess amount of acidity which is present in our body. Next is to decay caused acids. The bacteria present in our mouth convert sugar into acids. Whatever the sugar contents are there, it converts into acid. So that what happens, the pH will falls less than 5.5. It falls less than 5.5. So what happens, tooth decay will start. Your tooth eroding will take place. Is this clear? The excess acid has to be removed by cleaning the teeth with a good quality toothpaste. हमारे toothpaste में नमक है. I hope you have seen the type of advertisements. Yes. Why they will do that? Why they are adding iodine? Why they are adding salt in that? Because to increase the pH value, it should not decrease less than 5.5. If it is falling less than 5.5, tooth decay will take place. Soil of pH in plants and plant growth. Most of the plants have healthy growth when the soil has a specific pH close to range. Means usually I can say you that remember one word. The pH value of the soil should neither be acidic nor be basic. That's it. It should never be acidic nor be basic. It should be neutral. Then only the fertilizer will be good and plant's growth will be proper. Remember this word. It should be neither acidic nor basic. Example, we can see a compound X is sodium hydroxide. We can take one more compound here is zinc sulfate, sodium chloride, okay, sodium acetate. So we can take these are the different examples, which is neither acidic nor sodium hydroxide is completely basic. ZnSO4, zinc sulfate, sodium chloride, sodium acetate. So these are the different compounds. We need to, if sodium hydroxide is more, so what happens, if base is more, add acid so that the solution will become neutral. Then we can use to that soil. So salt are the ionic compounds. What are salts? They are the ionic compounds which are produced by neutralization reaction. Due to neutralization reaction, we are producing salt between acid and base. They are electrically neutral. There are a number of salts, but sodium chloride is the most common among them. Usually, sodium chloride is the most common salt which we are going to use in our daily life. Even that is also called as table salt, which we are going to use to cook the food. The characteristics of salt. Most of the salts are crystalline solid. They are opaque, transparent. They are soluble in water. They conduct electricity. The taste, we have different tasters, and they have taste also. Even they are odorless, means there is no smell for them, and they are colorless. Family of salt. So common acidic or basic radicals are said to be of the same family. Example, sodium chloride, calcium chloride belongs to the chloride family. CaCl2, that is again calcium chloride and calcium sulfate, they belongs to calcium family. Zinc chloride and zinc sulfate belongs to zinc family. So these are belongs to the same family of salts. Again, neutral salts we can see here. Please go through this table. It's important. They may ask you to balance this chemical reaction. What happens when sodium hydroxide reacts with hydrochloric acid? Sodium hydroxide reacts with sulfuric acid. Potassium hydroxide reacts with hydrochloric acid. What happens? Means that means just we are reacting with strong acid, strong base. Weak acid, weak base. That's it. In such a way. Okay. Strong acid, strong base. Done. Next, acidic salts. Salts, they are formed after the reaction between strong acid and weak base. Those are called as acidic salts. So I have just clarified these notes very clearly, very crystal cut. I have prepared the notes so that it will be easy for you to understand how the reaction and which reaction belongs to what. And these are the basic salts and how they are going to cause. It's been given the information here. pH of salt. So one is common salt. It is also known as table salt. Okay. And it is neutral salt, already we have discussed. And what is the pH value of common salt? That is 7. You should not forget this. It is 7. And we are going to use to taste the food. And sodium chloride is used in the manufacturing of many chemicals. That is the use of this sodium chloride. Now, important chemical from sodium chloride means here we have discussed some preparation and uses. So please study this and remember this process is known as preparation of sodium hydroxide. Preparation of sodium hydroxide, that is also known as chlor-alkali process. That is also called as chlor-alkali process. Okay. This is the preparation of sodium hydroxide, that is also known as chlor-alkali process, and uses of this. Bleaching powder. bleaching powder and the uses of this. This is a preparation method which has been explained over here. Please study this properly. How to prepare this bleaching powder and what are the uses of that. Okay. Same way baking soda, remember. So this is baking soda. It is also known as bread soda, cooking soda, bicarbonate soda, sodium bicarbonate or just bicarbonate. Okay. So preparation method. So this process is also known as solvay process. Remember, that is chloralkali process, and this process is known as solvay process. They may ask you briefly explain solvay process. Then you are going to write this. It's not brine, it is actually brine solution. Brine. Okay. And these are the properties of the sodium bicarbonate. This process is also known as dehydration reaction. Remember. Uses of baking soda, baking powder. It's very important, children. Baking soda and baking powder, very important, should not forget this. And this is washing soda, preparation of washing soda, uses of sodium carbonate, and this is very important, you should not forget what is water of crystallization. What is water of crystallization? So many salts contain water molecules, they are called as hydrated salts. The water molecule present in the salt, how much water molecules are present in the particular salt, is known as water of crystallization. Okay. Again, we are just recapping some basics like what are acids, what are bases, what are mineral acids, organic acids, hydronium ion, universal indicator, strong acid, weak acid, chemical properties of acid, chemical properties of main chemical properties of bases, indicators, pH scale, and actually this is a formula, but it's not there in your textbook. It's a numerical. In your higher studies, you are going to discuss this. pH is equals to minus logarithm of H, hydronium ions. Okay. And this is very important table, children. They may ask you washing soda, what is the chemical name, chemical formula and uses. Same way washing soda, baking soda, bleaching powder, plaster of Paris. Okay. So these are the different types of salts, and remember the chemical name, formula and uses of them. It's very important. And equations of acid, bases and salts, as what all the things we have discussed, what happens, acid react with metal, as a base react with metal, base react with acid, acid give hydronium ions and generate OH minus ions. So these are the things. And similarly we can see this, remember this main title, those are very important. Okay, you can expect definitely one more question based on these titles. And reaction of important chemical compounds like preparation of bleaching powder and preparation of plaster of Paris and preparation of gypsum, how we are going to manufacture gypsum. So this is the chapter acid, bases and salts. I hope you have understood the topic, and I have given the brief explanation over here. If you want any preparation or something, you can copy down the notes on this, and make sure that you have to complete the entire chapter. Okay, I hope you all have enjoyed this video. Wish you all the best of luck. Do well. Don't forget to like, subscribe, share and comment. Whatever you want, you can ask me. Definitely I will try my level best to help you all, children. Wish you all the best of luck. If you have got anything, any doubts, so please you can comment me or you can WhatsApp me. Again and again I'm repeating this. You can WhatsApp to my WhatsApp number also, 9964257448. Okay, whichever the chapter you are finding difficult or what problem you are facing, you can discuss with me. Definitely I will try to help you all. And share this video as much as possible to your other friends. Let they also utilize this opportunity to go through it. Thank you. Wish you all the best of luck. Bye bye.